Welcome. This is the final 3 videos, and in this one, we're going to estimate the instantaneous rate of descent at t equals 4 minutes. Now, remember that the instantaneous rate of change, well, that's equal to the slope of the secant line. Let's go ahead and write that down. This is equal. Not the secant line, excuse me, I misspoke. Wow, that's the average rate of change. The instantaneous rate of change is equal to the slope of the tangent line. And remember, a tangent line, unlike a secant line, has the same slope as the function it intersects at the point of intersection. So if I were to get my ruler here, let's see, here it is. I would want to match it up so that I got very close. And I'm going to zoom in real fast. Now that I'm zoomed in, you can see that when I move this ruler really close, it almost looks like that ruler has the same slope as the curve itself. That's what I want. So please, on your own paper, grab a ruler and get it to be just about the same slope as that line, and then go ahead and trace your ruler to get a nice straight line. Okay, so this here, in this light green, this is the line tangent, and I forgot to reiterate that this is the graph A of t, representing a plane's descent. Actually, I'm going to change this to modeling. And in green, we have the line tangent to A of t at t equals 4. And this is really important. It's tangent here only. And I'm going to do this since I can on my tablet. Oops, let me change something real quick. There we are. So if I were to move this line, notice when it intersects at 6, it does not look like it shares the same slope. Same thing at 7, here, at none of these points except for 4 does it look like this curve shares the same slope, or excuse me, this line shares the same slope as A of t. Now, since we don't know the function actually modeling A of t, we don't know what A of t equals. All we know is A of t is of this form, at squared plus bt plus c. That's all we know, but we don't know what a, b, and c are. So what we're going to do instead is we're going to use two secant lines. We're going to take the secant lines closest to 4. So we're going to look at this line here and this line here, those two secant lines. We're going to find the slope of those lines and then find the mean of that, and that will give us a good estimate of the slope of our tangent line. So to make it really clear what I'm doing, let me go ahead and draw these two lines. Okay, so here in pink, I have the secant line between t equals 3 and t equals 4. And let me go ahead and sketch another one now. Now, if you're able to, you should also be sketching this on your own paper. Those of you in my class are only given one graph, so I suggest you print out more than one copy if it will help you out. Here in blue now, let's go ahead and label this. This is the secant line between t equals 4 and t equals 5. So our plan here, our plan of attack, is to find the slope of this pink line, find the slope of this blue line, and then take their mean, find the average, because that'll get us pretty close, if not exactly the slope of the green line, which is this tangent line. And that's what we want. We want the slope of the tangent line, since that will give us the instantaneous rate of change. So the first thing we need to do is let's gather up some information. So for our pink secant line here, I know when t equals 3, A of t equals 2,550. And when t equals 4, A of t is equal to 2,200. And then for our other secant line, when t equals 4, that's one of our points. We already have that information. We're also using when t equals 5, A of t is 1,750. All right, so let's look at this one first. Let's look at this one. So let's look at V average for the first secant line, for our pink secant line. V average is equal to a of 4 minus a of 3 divided by 4 minus 3. So our input when t equals 3, remember this is the point, excuse me, not 3, 4. This is the point 4. This is a of 4. That's what this value is. So a of 4 here is 2,200. And from that, we're going to subtract 2,550 since that's a of 3 here. And let's go ahead and divide that by 1 since 4 minus 3 is 1. We end up with negative 350 tens of feet per minute. All right, now we can also look at this blue, our blue tangent line, which is no longer pictured, but you know, if you've been watching this whole video, you remember I sketched it in blue. So apologies for that jump in the screen. So the average rate of change is equal to a of 5 minus a of 4 over 5 minus 4. And you know, I keep doing this so this it's larger and smaller. That doesn't really matter. Honestly, I could switch them around and we'll still get the same result. But if I do that, I have to make sure to switch around what's in the denominator as well. So you don't necessarily have to go largest to smallest. And I'll switch it around on purpose for that reason, just so we can, you know, be sure of ourselves that it will still work out. So a of 4 we know is 2,200 minus a of 5, which is 1,750. 4 minus 5 is negative 1. So this numerator produces 450 divided by negative 1 in our denominator, so negative 450 tens of feet per minute. Okay, so now let's estimate, finally we're going to estimate the instantaneous rate of change, so the slope of the tangent line at t equals 4 by computing the mean of the two slopes above. Before I do that though, I want to quickly circle back to our picture. Okay, so we're back at our picture, and the reason I wanted to come back here is just to make it really clear. I could have picked other points. I could have done this secant line here and this secant line here and found their average. But their average is going to be more like this, which isn't going to be that accurate. These two are close enough that their average is going to be somewhere in between here, that slope. And so that's going to be pretty close. So the idea is when you're estimating the slope of a tangent line or an instantaneous rate of change, also can be referred to as instantaneous velocity. You know, all of those are interchangeable. Slope of the tangent line, instantaneous rate of change, instantaneous velocity, all of those are interchangeable terms. So when you're estimating that, you can choose any 2 points you want on either side, the way I did here for these secant lines, but it is in your best interest to pick the two closest. And since I wanted to estimate it here, I picked 3 and 4 and 4 and 5, but I could have picked any other points. That said, let's go back to our computation. All right, so V instantaneous, and that's just an abbreviation, V instantaneous, you know? It is not a typo. So V instantaneous is approximately, and I'm going to quickly label this V average 1, V average 2, just to make it clear which is which, without having to rely on colors. So it's the average, or the mean of V average 1 and V average 2. And to find the mean, we add these two values, after I ignore these typos, of course. Okay, so let's add those two values and divide them by 2. So we end up with negative 350 minus 400. Oops, 400. Let's stick to this form exactly. So plus negative 450. That's why I had done minus in the first place. So this is negative 800 divided by 2, which is negative 400. Okay, let's go ahead and write out a sentence explaining our answer. Okay, I've made a little bit more space here so I can write out my explanation here on the side. The plane is descending at about 4,000 feet per minute, exactly 4 minutes into descent. And I just realized I forgot to put the units here, so let's do that real quick. This is tens of feet. I'm going to redo this, that's too messy. There we go. So let's do the units right here. Sorry for all that jumping around. Oh my God, and I'm still jumping around. Sorry, touchscreens are like that. You touch them in a weird place and everything moves. So this is tens of feet per minute. That's all I have for you for this example. Please, if you're in my course, I hope you watched all 3 videos. Otherwise, please keep calm and math on.